Alright, so welcome to 7.1 Trigonometric Identities. Today we're going to have basically three main questions to answer about identities. What are the reciprocal identities? We're also going to talk about the Pythagorean identities. So we're going to figure out what are the Pythagorean identities. And then the last question we're going to answer is, how do we prove identities? Now this chapter is going to be a little difficult for some of you. We're going to have to memorize some identities, but don't worry, down the road I will be giving you a note card that you can use all the formulas. But today's lesson, any identity that I talk about in terms of the basic ones, you're going to have to learn to memorize, and I will teach you some ways to memorize some of them. But first, let's do some algebra review. As we do this, I would encourage you to pause the video and see if you can do the example by yourself before you actually see my written answer. So after I write down the problem, I would pause the video and try the problem. So the first problems we're going to do are factor. So we're going to factor x squared minus x minus 20. So again, I would pause the video and see if you can do this. Remember, when you factor, you're going to make a double set of parentheses because you're forming a product. And that is your answer. The second one's a little more difficult. Factor 6x squared plus 2x minus 28. Now the first thing that you want to do when you think about this problem is you always look for a greatest common factor. So in this case there's a greatest common factor of 2. So we're going to factor that out. Now that made our problem considerably easier because we know when we do the double set of parentheses that with having a prime number 3, there can only be one pair of factors that work, and that's 3 and 1. Now at the end, we know it's either going to be 14 and 1, 1 and 14, 7 and 2, or 2 and 7. Looking at this negative sign means that 1 has to be positive, 1 has to be negative, so it ends up being plus 7 minus 2. And when you do factoring, I just guess and check, so try something and then distribute it and see if it actually gets to your trinomial. Now the last problem is the hardest problem. Now many of you were taught a different way last year to do this. I just do this guess and check similar to the problem above, but I'm going to show you how some of you were taught. You were taught to multiply 8 times negative 45. So take the first one times the last one, and you would get negative 360. Then what you need to do is you need to start thinking about the factors of negative 360 that would combine to make 2, positive 2 in this case. So like you might think 36 and 10, negative 36 and 10 would make negative 360, but they would not add to positive 2. So then you keep trying some other factors. 20 and 18 are obvious answers. And if you put a negative in front of the 20, negative 20 and 18 doesn't make positive 2. But positive 20 and negative 18 does make positive 2. So those are the factors you're going to use. So you're going to rewrite the first term. And you're going to write these two terms. Basically, you're splitting the middle term into positive 20x minus 18x minus 45. Now to complete this problem, you're going to do a process known as factor by grouping. You're going to group the first two terms, and you're going to group the last two terms. So the first two terms, you're going to factor out the greatest common factor of 4x. The last two terms, you're going to factor out a negative 9. Then, if you look, they have a common factor of 2x plus 5, 2x plus 5. So what you do is you factor out the 2x plus 5, and then you write what's left over, 4x minus 9, and that would be the answer to your factoring of 8x squared plus 2x minus 45. Let's move on and do some more algebra review. What if we wanted to add fractions? So 3 over x plus 2 plus 5 over x minus 4. The first thing you need to do is find a common denominator. So again, try this problem on your own and then see if you can get the answer. So pause the video. Multiply by x plus 2 over x plus 2. Multiply by x minus 4 over x minus 4. That's a clever form of 1. When you do that, you can go ahead and distribute the top, 3x minus 12, plus distribute the top, 5x plus 10. Because you made a common denominator, it allows you to add the numerators. So I just jump to the step of x plus 2, x minus 4. Combine like terms in the top, 8x minus 2 over x plus 2, x minus 4. Now you should check to see if the numerator factors, to see if potentially something on the bottom would cancel out with it. So in the top, you factor out a 2. You get 4x minus 1 left over. But you can see that nothing would factor out because we have no common factors. Alright, let's move on to one more algebra problem. Simplifying. What if we had 3 over 2 plus the square root of 5? Now there was something that we needed to do right here from last year. There was a word that started with a C. Let's think for a moment. What could that be? Oh yes, we have to multiply by the conjugate. So the conjugate was a clever form of 1, and it was the opposite operation of the term. So this is the conjugate of the denominator. And when we do that, we multiply the 3 times the 2 and the 3 times the negative square root of 5. So we get 6 minus 3 square root of 5 over, and then we have to FOIL or distribute. We have to take the 2 times the 2, which is 4, 2 times the negative square root of 5, which is negative 2 square root of 5, square root of 5 times 2, which is positive 2 square root of 5, and positive square root of 5 times negative square root of 5 would be negative square root of 25, but that would just be negative 5. So then we simplify, we get 6 minus 3 square root of 5 over negative 1. And we can just divide everything by a negative to make it look a little cleaner. And that would be our answer. All of those algebra skills are going to be used in this chapter, and you'll see them come into play today in different kinds of ways, or in your homework. But we're going to talk about the reciprocal identities. The reciprocal identities we kind of already indirectly know. We know that the cosecant of x is equal to 1 over the sine of x. This is something you have to remember for the chapter. We also know the secant of x is equal to 1 over the cosine of x. And we know the cotangent of x is equal to 1 over the tangent of x. These are reciprocal identities that you did last year. And conversely, the sine of x is equal to 1 over the cosecant of x. And the cosine of x is equal to 1 over the secant of x. And the tangent of x is equal to 1 over the cotangent of x. But because of these reciprocals, we can take another step. They're not really called reciprocal identities, but I kind of lump them together because the tangent of x, due to all these definitions and the definition of the tangent, we know the tangent is y over x. Well, if the tangent is y over x, then that is actually going to be equal to sine over cosine. And because of the reciprocal identities, we know that the tangent and the cotangent are reciprocals. So if that is true, the cotangent would equal the cosine of x over the sine of x. So those are the reciprocal identities. You need to know all of these. I will not give you these on a formula sheet. Moving on to the Pythagorean identities. We're going to prove the Pythagorean identities. Using this triangle, we know that x squared plus y squared equals r squared. Well, we know that r is supposed to be 1, so x squared plus y squared equals 1 in this case. We also know if that's true, then the definition for x would be the cosine. So we would say the cosine squared of theta plus the sine squared, because that's the y value, would equal 1. This is our first Pythagorean identity. You must know that. I'm sorry I don't have any good way to memorize it. However, if we watch what happens if we take the cosine squared theta plus sine squared theta equals 1, and we divide everything by the cosine squared. If we divide everything by the cosine squared, we get 1 plus, now sine over cosine is tangent, so this would be tangent squared. And 1 over the cosine, well, we know the reciprocal is the secant, so this would equal the secant squared. This is another one you have to remember. What if we took the cosine squared theta plus the sine squared theta equals 1, and we divide everything by sine squared? Well, cosine over sine is cotangent, so this would be the cotangent squared. Plus sine squared over sine squared is 1. 1 divided by sine is the secant. Excuse me, the cosecant. So that'd be cosecant squared. That's another one you have to remember. Now, these 3 stars are the ones that you have to remember, but I want to caution you that you also should recognize them in alternative forms. For instance, if I take cosine squared plus sine squared equals 1, and I subtract, so what if I have sine squared theta, and I subtract the cosine squared to the other side? 1 minus cosine squared is also an identity. Similarly, if I take 1 plus tangent squared equals secant squared, I could say 1 equals secant squared theta minus tangent squared theta. So there's all types of what I call alternate forms. So alternate forms. Don't memorize these. They're just algebraic manipulations. Like all you're doing is moving things to sides. Opposites, positives, things like that. Remember, undoing certain things to both sides. It's your algebra 1 roots of basic solving equations. Just remember the 3 stars. Now, I do have a great way to remember the 2 ways at the bottom. The last 2 that we developed, I wouldn't expect you to derive them each time from the cosine squared plus sine squared equals 1. That's one you have to remember. But the other 2, if you think of, there's always a 1 on both sides. If you see there's the 1 on the left side. If you want to remember these, think about socks. Now you say, Mr. Lightfried, why are you telling me about socks? Well, if you look at the left side, what do we know about tan socks? Tan socks are sexy. If you look at the word tan, it looks like the tangent. And if you look at the word sexy, it kind of looks like secant. S-E-C. I know, enjoy that one, right? I mean, I learned that from a colleague of mine, and I just think it's, over the years, it's just a really good way to remember it. Cotangent squared theta plus 1 equals cosecant squared. Well, what do you know about cotton socks? We know cotton socks, they are so comfortable, they are cozy. So cotton socks are cozy. So you got to remember the 1 plus something is on the left side, but you think about tan socks being sexy, cotton socks being cozy, you'll never forget these Pythagorean identities. Now, we're going to talk about some practice. How do we use these identities, or how do we make them up? We're going to use them later in the chapter to solve equations, but to practice them and to kind of get learning them and reinforce our algebra skills, we have 2 different types of problems. The first problem is when they ask you to simplify. Now, in the interest of time and making the video too long, I'm going to do the first problem, and then I'm going to download these notes onto our website, and so I would encourage you then to try the next 2 problems.